Hello. Welcome back to another video, and today I'll be showcasing my industrial safety and health presentation I made using pandas and data visualization. Okay, so let's begin. I'll first show you my PowerPoint. Okay, industrial safety and health. So I put my author information right here. You can take a look at it. The link to my GitHub page should be posted in the YouTube description as well. So let's begin with the introduction. So what is the data set? What type of data set are we looking at? Well, this data set shows the occurrence of accidents from 12 different plants in 3 different countries from 2016 to 2017. The primary reason the author is sharing this dataset with the community is to encourage the exploration of the data and the generation of insights that manufacturing plants can use to improve workplace safety and ultimately save lives. As such, this presentation aims to explore the dataset, uncover meaningful insights, and provide findings that manufacturing plants can use to improve workplace safety and help save lives. So let's look at the dataset link. This is in Kaggle, and this was made in around, this was made, I think, back in 2016 or 2017. I believe 2017 is when it was from. And yeah, it's mostly used to generate a lot of insights from many different people, students, other companies, things like that, to ensure that people are safe in these industries. Okay, so let's go back to the slideshows, and let's move on to the description of the dataset. So here is what the dataset looks like in my mouse pointer, and as you can see, we have the features shown in the 9 columns. So the first is the date, which tells you when this incident took place. The country is labeled in the second column, and the local is representing the what plant it was. So each local is a different plant, and there's 12 plants in total. The industry sector tells you which it is. Some might be mining, some might be metals, some might be other industries as well. The accident level is how severe the incident was. 1 is the least, and 5 would be the max, and the potential accident level would be the worst case scenario of the accident if the accident that took place ended up being really bad. And that would be for instance, this person in this country, in this plant, in this sector of the industry, got into a very minor accident, but it could have been very bad, and he could have lost an arm, something like that. The genre is the gender or the sex of the employee. The employee autorisero, that is what type of person it was. Third party, there's 3 types in this data set. There's third party, which is people who are not employed in the mine. Employee are people who are employed, and third party remote are people who are not employed in the mine, and who got into this accident away from the mine. So if for instance someone got into a crash with a truck driver who's part of this company, that would be a third party remote, because this accident didn't actually take place inside the mine, it took place outside the mine. Okay, so those are the features. I also wrote down the definitions here. You can kind of look at them, pause the video if I didn't really explain that well. I hope I did. There's definitions for this. Then there's definitions for employer autorisero. Again, there's 3 types. And then there is finally definitions for accident level and potential accident level. Again, this one is severity of the accident that occurred, and this is what could have been under very different circumstances, like the worst case scenario of the accident. Okay, and this is our intuitive severity scale. So number 1 is very low, and it's very minor accident, but number 6 would be very extreme, and it would be catastrophic, fatal, could be lawsuits, things like that. Okay, so let's take a look at some exploratory data analysis that we're going to look at. Okay, so I did leave a note here. I said that all of analysis is in this report is based solely on this data set. Other than the information provided by the dataset's author, I have no way of verifying where the data came from or how it was collected. So the dataset may contain limitations or biases, such as like confidentiality or incomplete reportings that might have occurred, and these limitations should be kept in mind. So this is just me being upfront about this. As a result, the analysis in the project is intended to simply just identify the patterns that could lead to further investigation rather than making claims about the industry as a whole. So therefore, this finding should be viewed as observations on available data, but not as conclusions that apply to the general population. And that's inferential statistics, right? Okay, so let's begin with some basic information. The table below provides a summary of the key characteristics. The count represents the total number of records, so there's 439 records in total. Unique shows the number of distinct values. Date makes sense, 287, and then we can see for countries, there's only 3 countries, there's 12 plants, 3 industries, 5 accident levels, but for potential accident level, there's 6. For gender, there's 2, male, female. Employer terrestrial, there's 3 types. And for risco criteria, we can see that there's, and by the way, risco critico, that just means what type of accident that took place. That just means like, okay, well, how many categories are there? There's 34 categories. Top is like the mode of the data set, so like which one is the most frequent of them. And we can see this date is the most frequent of them, and in this date there were 13 of them that occurred. Country 1 is the most frequent country with 263 of these accidents occurring from the specific country, and local 3 being the maximum, with 90 of these coming from this local plant. Just so you know, where the data set didn't mention whose country this was or whose plant was this, probably for the sake of keeping things private. But yeah, I just wanted to let you know that this information about where these accidents came from is not public. Industry sector, mining came up with the most, with 241 of them. Accident level, we can see that most of these accidents were very minor with 328, but we can see that with the potential accident level, 4 is the most frequent one with 155 of them, showcasing that most of these accidents could have been pretty dangerous. We can see that most of these workers are male, and that third party is actually the most frequent of these accidents with the risk of and as you can see that most of these accidents are classified as others with 232, so most of these accidents, we don't really have information on what actually caused these accidents. Most of them are set as other. But anyway, let's go into this where I basically show you the visualization part. So this is what we talked about, frequency counts of accident levels. Potential accident levels right here shows that many of these incidents could have been much more serious if circumstances had been different. And you can see accident levels, most of them are minor. And what this shows is that we have to take even minor accidents very seriously, because this could have led to something really, really bad, right? Yeah. And that's the insight that came from this. Don't ignore minor accidents. Accident distribution based on country. Country of 1 has the greatest number of accidents, but this could just be because there's more industry in that country. This is just purely numerical. So we cannot say for sure that country is less safe. As for the 12 plants, they also follow very similar trends. So like they don't really they also follow very similar, where like a few of them dominate over the others. But again, we don't know, maybe the plant is bigger than the other plants, so on and so forth. So what we're saying basically is that the number of accidents on a country may not be just related to the actual safety output of that country. It could be because there's more industry at that country. And this is based on industry. We can see that mining has the most out of all of them, but metals falls pretty close. So it shows that the most high risk working environments would basically be metals and mining. Others, we're not 100% sure what they mean, but this could be just other. This just goes to show that mining and metals are the industries that cause a lot more accidents than other industries. Okay, accidents based on sex. We can see that most of these people are male, and 5% female. That basically makes sense because the workforce makeup of most of these industries are mostly male. So it makes sense that most of these accidents are for male, and unless we know the actual proportion of male to female in these industries, we cannot make a general conclusion that males or females get into more accidents. It's just that there's just a more number of males than there are females in these industries. Okay, accident distribution based on person. We can see that third-party persons are mostly what make up these accidents, and that's very surprising because you would expect them to be employees that make up most of these accidents. So obviously this would stand out to me. So this may suggest that third-party workers, such as contractors or visitors, may not be familiar with the site safety procedures or work environment as maybe regular employees would be. And so it may suggest that more attention may be needed to ensure everyone on the site, even people who are not employed on the site, is properly informed about safety procedures before coming onto the site so that they don't get hurt. And that is accident distribution based on person. Cause of injuries. Cause of injuries. There are 34 unique causes. However, more than half of them are grouped under others. So it really makes it difficult to determine which one is the most common ones. Even so, the data reveals some insights, right? You can kind of look at the ones that were not put in others, and we see that there were some of these accidents that were put against venomous animals or bees, as you can see here, showing that even hazards that are not directly related to the equipment or operation of the mine are still important to look at. So you have to take appropriate precautions against those environmental hazards, even if they are outside the company's control. So if venomous animals and bees are a problem, it should be the company's priority to ensure that those accidents don't occur, even if they're not because of the company itself. Okay, accident level and potential accident level. So I used a custom function in Pandas, and I figured out the mean. I converted the Roman numerals to integers or else we can't really do all of these mean and mode. We can't really apply the mean method to the data frame. And I found this. The average accident level in just regular accident level is just 1.5. So that's the average of the severity of the accident, and the potential accident level is around 3.0. So it really shows that on average, the actual accident that occurred is around half the severity of its worst case scenario. And the next slide, the next slide shows how the standard deviation of the ratio. So here we see the ratio mentioned from last slide is 52.4%. That's pretty much around half. And standard deviation of the ratio, 27.8%. So just moderate variability, meaning that though accidents are generally about half as severe, they are proportionally differed, or its outcomes are differed noticeably across individual incidents. So even if the average is half, there's still a good chance it won't be half. It might be less than half, or it could be way more than half, so on and so forth. Okay, and for our final analysis, we see that I grouped all these accidents based on their month, and we see that both the 2016 March and 2017 March stand out as the most of these accidents. It may be coincidence that these guys were the ones that peaked, but it could suggest that different times of the year contribute to a higher number of accidents. So we should look at whether accidents are seasonal conditions, whether maybe they came from break or something like that. So we just need to make sure that, okay, well, these might be coincidences because we don't know if this continues, but we need to make sure that certain parts of the year are a little bit kept more unchecked, so that these peaks don't occur. We don't want these seasonal peaks to occur. That shows that something's wrong, right? And yeah, that is the end of my slideshow. I hope you guys had a fun time listening to me, and that's the end. Thank you for listening to me, and I'll see you next time.